Hello everyone. Hello everyone. In last video, we have talked about like how the uh, NMOS works in different regions. Like I already specified this. Okay. In this video, we will see the same things, similar analysis about the PMOS. Okay. So come to the PMOS. So PMOS I already told you like we have to calculate VSG. In NMOS we were considering VGS. So in an PMOS, we will consider VSG and then we will take mod of VT. Similarly, instead of VDS, we will calculate VSD, and instead of VGS, yeah, VSG, and all the conditions would be same. Like if this condition is true, then we will only move to step 2 and so on. Okay, so this is like very much similar to NMOS. Okay, PMOS is very much similar to NMOS. Only the main difference I've told you, if you know only one analysis in a good way, then you can do other one. It won't be a like a very difficult task. Okay, so come to the reason. Okay, so suppose I am taking reason one. Okay, so in reason one for PMOS, I will take V in and I will choose my V out. Okay, so it will be same like if I'm considering this as my region one, like and most में हमने भी यहीं से start करा था कि this is my region one. यहाँ से मैं start करता हूँ region one को analysis. like V in जब मेरा 0 होगा तो VRTD मेरा क्या होगा 5 वोल्ट होगा. फिर से देखो, अगर एनमॉस का नहीं देखा तो V in अगर मेरा 0 है तो VTD क्या होगा मेरा 5 वोल्ट होगा. ठीक है, तो let's come to analysis part. So what I told you कि अगर मेरा वी इन जो है वो 0 वोल्ट होता है. ओके, सो मेरा जो वी आउट होगा वो कितना होगा, वी डी डी के इक्विवेलेंट होगा एंड दैट विल बी लाइक 5 वोल्ट. ओके, फाइन. Okay, now we will come to the step one. We will calculate VSG and mod of VT. So let's perform the step one. What we have to calculate? We have to calculate Vs of G and then mod of Vt, and we will compare it. So again it will be Vs minus Vg and this would be mod of Vt. Now here the things is like अब हमारे पास क्या है, PMOS है. ओके, सो PMOS का सोर्स का वोल्टेज माइनस PMOS का गेट का वोल्टेज. अंडरस्टूड. दिस मीन्स कि PMOS का जो भी सोर्स का वोल्टेज होगा और PMOS का जो भी गेट का वोल्टेज होगा दैट वी नीड टू माइनस. ओके, सो वी विल गो फॉर PMOS. हियर इट इज. Here it is. So source का voltage. What is source? VDD. Okay. What is source? That is VDD. And source का voltage कितना हुआ? VDD. Source minus gate. Gate का voltage कितना हुआ? Vin. So instead of V source, we will write VDD. And instead of V gate, we will write Vin. Okay. I hope I am clear to you. Uh, if you are not comfortable with this, I would recommend like you to please watch previous videos. They are in the sequence, and if you watch in sequence then there would be no trouble with you. Okay, still I am making my best, like from wherever you start you will get the things. So what I told you, VSG will be VDD, and on the gate it will be Vin for PMOS, and this would be my mod of VT. So what is VDD? It is 5 volt. Okay, and what is Vin? What is Vin? Vin is 0 volt. Okay, so I have already taken like Vin 0 and it would be taken from here. Okay, and VDD we know. Okay, mod of VT is 1, so obviously this value is going to be greater. Okay, so if this value is greater, if this value is greater, okay, now tell me what would be my next step. Yeah, you guessed it correctly. If my VSG is greater, if my VSG is greater than mod of VT, it is true, then we will move to step 2. So coming to step 2, we will calculate VSD and VGS minus VSG minus VT. ओके, मेरे मुंह से भी कई बार VGS का VSG हो रहा है, बट आई मेड इन माई माइंड क्लियर, लाइक NMOS होगा तो मेरे को VGS निकालना होता है और PMOS होगा तो मेरे को VSG निकालना होता है। ठीक है, सो this is the fundamental thing which you keep in your mind. It will be helpful for you. Okay, so what next? So next, let's calculate step 2. So I have to calculate VSD, okay, and I have to calculate VSG and minus mod of VT. अगर मैं ध्यान से देखूं तो I have calculated my VSG. See, this was VSG, so its value is coming 5 volt. So I will try to write it directly. Okay, I will try to write it directly. Like this is my 5 volt. Okay, and this is my 1 volt. Okay, I will write it directly, and this is my V source minus V drain. So again we will go to the PMOS and let's see like what happens at source and what is the voltage at drain. So now V source minus V gate. V source is always connected to VDD, and V drain is always connected to the V output. Okay, V source is also V source is VDD and V drain is V out. Let's take it. Let's take it. V source is what? Tell me. It was VDD. Sorry, it was VDD. And VD. VD is what? Drain पे क्या connect था? Output. This would be like this would be of 4 volt. So VDD minus V out. Now we have to calculate. So VDD is always 5 volt. We know. V out is what? Now you tell me. What is V out? Yeah, we have already calculated it. V out 5 volt. Now tell me. Obviously this would be greater than this. Now tell me, if this was greater than this, then it would be in saturation. Otherwise, this is in the linear. Okay, so for your reference, let's move to the boundary condition and check. So VSD is less than VGS, VSG minus VT, it would be in the linear region. So it is occurring as a same. Okay, it is going as a same. Like VSD is less than VSG minus VT. See, so what would be its answer? Its answer would be region 1. I will write region 1 is in linear. Fine. I hope I am clear to you. Okay. So this was all about region 1. Now we will see for region 2. Okay. Now same. रीजन 2 के लिए भी हम वी इन कैलकुलेट करेंगे, वी आउट पता होना चाहिए, ये दो चीजें हमें पता होनी चाहिए, एंड दीज टू थिंग्स वुड बी टेकन फ्रॉम द ग्राफ ओनली. So what would be my V in at region 1? This will be V of IL, and V of IL, which is 1.8, and corresponding to it the value would be near about VOH, so we can take it as a VDD. Okay, you can see and take the value from the NMOS also. See, V in is 1.8 and V out is 5 volt, so these two things are basically similar in NMOS. Okay, so V in will be VIL, V in will be V of IL, and that is 1.8 volt, and V out is what? Near about VOH, and that value is approximately 5 volt. Okay, fine. Again, similar, step 1 we have to perform like V S of G and mod of VT. What is the relation between them? So I will write VS minus VG, and I will write like this. So what is source? Source is always connected to VDD, we know. And what is gate? Gate is always connected to V in. You can recheck. Okay, and this will be my 1 volt. So what is VDD? 5. What is my V in? Now my V in is 1.8. Okay, obviously this value would be much greater than 1. Okay, so if this condition is true, we will move to step 2. Now coming to step 2, okay, coming to step 2, what we need to calculate? What we need to calculate? Tell me. VDS, sorry, VST. Okay, in PMOS we calculate Vs of t, and here we calculate Vs of g minus of mod of Vt. Fine. Now we will check like which inequality is suiting this. Okay, fitting this. So VSG I have already calculated. You can see. And what is this? 5 minus 1.8. I will write it as it is. And mod of Vt is 1. So what is source? Source पे मेरा क्या connect होता है PMOS में? And what is like VD? So source पे मेरा VDD connect होता है. Drain पे मेरा V out connect होता है. Okay, so what will be? I will keep it as like 4 minus 1.8. Okay, what is VDD? So VDD is my 5. Okay, and what is my V out? Tell me, what is my V out here? 5 volt. So obviously this value would be much greater than that, because at least this would be positive, some positive. Okay, some positive, and this is 0. Okay, you know, don't need to calculate the exact value, you just only need to check the inequality. So you can see like if V of SD is less than Vs of G minus mod of Vt, then what happens here? Vs of D is less than this. Again, this will be the similar to previous one, and that would be the linear region. So what I can write is uh, region 2 is in linear. Fine. Is it fine? Okay. Now come to the linear 3. Come to the sorry, region 3. So I will take like region 3. I would recommend like you should pause the video and now you can try at your own, because this much example is sufficient. The same things is happening again and again. I'm just checking the boundary conditions and these things. So these are the fundamentals. If these are the things which you have clear in your mind, then it's not a very difficult task to do the analysis of NMOS or whether PMOS. So I am going for region third. So tell me, when I go for V in thirds, like VDD by 2. So at VDD by 2, my output will be also VDD by 2. Okay, so V out is also VDD by 2, V in also VDD by 2. Okay, let's go for this analysis. My V in is VDD by 2, and which is equal to 2.5 volt, and V out is also like same, and that is also 2.5 volt. Again I have to what perform the same step like step 1. I have to calculate, I have to compute uh, what is the value of my step 1, like V s of G and mod of V of T. Fine. So it will be Vs minus Vg, and this would be mod of Vt. Now tell me, source is connected where in PMOS? It is always connected to VDD, and gate is connected to V input, and this is like, so VDD is 5 volt. Okay, V in is like your 2.5 volt, and this is 1. So this value should always be greater than this. ओके, सो ये स्टेप आने के बाद से हमारा स्टेप 1 ट्रू होने के बाद से वी विल मूव टू स्टेप 2, एंड इन स्टेप 2 व्हाट विल कैलकुलेट, व्हाट वी विल कैलकुलेट, वी विल कैलकुलेट we will calculate Vs of t and Vs of g minus V of t. So this value we have to calculate. So it would be Vs minus Vd, this would be minus Vs minus Vg, and this would be mod of Vt. So now tell me, what is the value of source? So in PMOS, source is always connected to the drain voltage, sorry, VDD. Okay, and VD, which is a drain voltage. So drain is actually connected to V out. Okay, you can verify, you can cross verify. Okay, VS is like VDD, and VG is like V in, and this is minus 1. So you see I have already calculated this VDD minus V in, 5 minus 2.5. So this value would be like 2.5 minus 1, and this would be minus 1, and VDD is my 5 and V out is also 2.5. So I have taken V out as 2.5, you can see from here. Okay, it will come to be out to be 2.5. So अभी मेरा क्या आ रहा है, so it will be like 2.5 here, and there is something 2.5 minus 1. So something is better than something minus something. So always, yeah, you can calculate exact value also, but there is no need. This value will be greater than. Only the thing is I need to know this equality, inequality. So yeah, so this is like opposite to the previous cases we have seen. Here VSD become greater than VSG minus mod of VT. So now we can see if my VSD is greater than equal to VSG minus mod of VT, then what will happen? It will be in the saturation region. It will be in the saturation region. So can I write here? Can I write here? What? What I can write? Like my region 3 is in saturation. My region 3 is in saturation. Okay, my region 3 is in saturation. Fine. Okay, so after this analysis we will move to the region 4. Okay, so in region 4 we have to check two things: what would be the value of my V in and what would be the value of my V out. So let's move to the region 4 and check what would be my value of V in and V out. Yeah, you can take the values from here also, as we have calculated for NMOS, and you can take the value from the graph also. So I'm explaining from the graph. Like my V in is like, now Vi of H I have to take, which is 2.8, and corresponding to this the value will come to be near about VOL, not exactly VOL, near about VOL. So something less than VOL or near about 0 I will consider as a 0. So what I told you, like V out is my Vi in is Vi of H, and that value is 2.8 volt. And in the V out what we have seen, near about to VOL. So this value is 0 volt. Again, we have to do the same analysis. I will recommend you to stop the video and do the analysis on your own. In this way, you will gain confidence. So basically, I have to check what is the relation between these two values. Okay. So first value I have taken VSG, and second is my mod of VT. Now this is my VS minus VG. Okay, and this is like mod of VD. So V source, so we already know, like for PMOS the source voltage is connected where. So the source voltage is always connected to the VDD voltage, and the gate voltage is always connected to the V in. Okay, and this is my mod of VT. So now VDD is my 5 volt and V in is my what, my input, which is 2.8 volt, and this is 1. So still this would be greater than 1. So this condition is true. So if this condition is true, I will move to step 2. And in step 2, what I have to calculate, VSD and VSG minus mod of VT, and what the relation they hold. Okay, so Vs minus Vd and VSG I have already calculated, like you can take from here, 5 minus 2.8 volt minus of 1, because my threshold voltage is mod of 1, and Vs, which is my source. So source is always connected to VDD, and my drain is always connected to V out. Okay, so this inequality will be like, I can write here 4 minus 2.8. Okay, Fine. So VDD is 5 and V out is what? 0. So I hope I'm clear to you. This value would be greater, and we know like whenever a VST is greater than this VSG minus mod of VT, then we write as a saturation. You can verify from above also, from the boundary condition, like VST whenever it is greater than this, our region of operation is like saturation. So can I write here region 4 is in saturation, region 4 is in saturation. Okay, fine. Now the last reason, the last reason, which is reason 5. Now you are grown enough to do these things on your own also, so I will recommend you to please do this on your own. So what would be my V in and what would be my V out? So my V in would be like VDD, if I'm not wrong. See, from the graph we can see my final V in value would be like VDD, and corresponding to this VDD, when this VDD come, my V out becomes, sorry, so corresponding to my V in, VDD is there, and corresponding to this VDD, my V out will come to 0. Okay, so V out would be 0, V out would be 0, my V out would be 0, and my V in would be VDD. So can I take here, can I take these values, like my V in is my VDD, which is equivalent to 5 volt, and my V out is what? Can you tell me? V out is what? 0 volt. Now again I have to perform my step 1. I have to calculate VSG and VT. I hope I'm clear to you. Vs minus Vg and mod of Vt. So mod of Vt is 1. Vs is like source voltage which is always connected to the drain, and Vg is like V in. So VDD is 5, V in is my 5. So this is 1. So this inequality would be like this. So now tell me, if VSG becomes smaller than VT, what will happen? If VSG is smaller, so if greater, then we will move only to step 2 now. If this is smaller, this means it comes under the category of false. So that means the reason is cut off. Fine. So what I can write is my reason 5 is cut off. So I hope I am clear to you. Now I need to summarize it. So I will summarize this with the help of a table. So this was all about NMOS and this is all about PMOS. So region 1 was linear, region 2 was linear, 3 is also saturation, 4 is saturation, 5 is cutoff. So now you can write over this, like for NMOS this region would be what for NMOS this is what? Cutoff, then saturation, then region 3 cutoff, region 1, second is saturation, third is also saturation, and fourth is linear, fifth is linear. So for NMOS, first one is, you can write here, cutoff, saturation, then linear, and then add the last linear. And for PMOS, first one is like your linear, then again linear, then saturation, and then cutoff. So you can show it on a graph also. So I hope I am clear to you, and every concept is clear to you. If you don't understand, I would recommend like go again and revise this video again and again. uh, Take up pen and paper with you, solve this through, and I hope you will get it. So thank you everyone. Thank you.